Hello there. My name is Aluko Samuel Kayode. I will be taking you through the practical steps in mathematics on how to solve every mathematical questions. All right, welcome back. We'll be going on logarithm now. After we're done with the indices, we've done a little on indices, just like an introduction. We have some other complex questions. But, a logarithm is just a mirror of indices. So we just consider some basic law in logarithm. So we just say laws of logarithms. So it's just a mirror image. It's just a mirror of indices. So first law, okay. So if you have log mn, you have log m and n. So it's log 1. It's the same thing as log m. Now, note, you must always have a base. If you don't have a base like this, it simply means base 10. But let's put a base now. Let's say x simply means log x m plus log x n. Log x n plus log x n, because there is always a base. So most of the time, if you don't have that base being written here, it simply means log 10. So law 2, if you have log x m divided by n is log x m minus log x n. So you will discover that this is just the same thing as when you have the indices. I told you it's just the mirror of indices. When you have a raised to power x, remember this is the base, this is the power, multiplied by a raised to power y is the same thing as ax plus y. And when you have a raised to power x divided by a raised to power y is the same thing as a raised to power x minus y. So you can see this is just the mirror of this to this. They're just the mirror of one another. So then when you have another law says that when you have log of x m n, let's use n. This is the same thing as n log x m. So this is also very straightforward. So let's take a few examples. Just take a few examples before we start combining most of others. So let's take some few examples. I just take some few examples now. Let's take a few examples. So if you have log 10 log base 10. Remember, I told you even if this is not written, it's still the same thing as log base 10. So I can decide to write it like this or just put it. But if it is any other base, you will be given of 2. Let me write it. 2 multiplied by 3. This is the same thing as log 10 log 2 plus log base 10 3. So you have this can simply be expressed as this. Very, very straightforward. But what about if you have it as log 10 2 divided by 3? This also will be 10 2 minus log 10 3. Simple and straightforward. So, but what about if you have it as let's take this also, this one also. If you have it as log 10 2 raised to power 3, this will also be, remember, you bring this 3 to the back here, you have 3 log 10 base 2. You can see, simple and straightforward. But let's take some other complex let's take some complex examples. if you have let's take as this is 4. You have log base 10, it's 1 minus log base 10, 3. You're being asked to solve this. So what do? Look at this. Come back to this, just a reverse of this very law. You can see log x n divided by n is equals to this. So what you do, you just say, okay, yes, okay, this is the same thing as log base 10, 81 divided by 3. Did you see that? 81 divided by 3. So 81 divided by 3, look at this. This will just be 27, right? So this is log 10, because 3 here, 1, 3 here, you have 2, you left 2, bring it there, that's 21, that will be 7. So log 10 base 27, straightforward. Log 10 base 27. Can you simplify that further? Is it possible for you to simplify that further? Yes. So you have that straightforward. So this log base 10 27. So you want to take that further, but for the sake of this very introductory, we'll not be taking that further. You might want to take it further. Yes, that's fine, but let's just leave it as this. So let's take another example. You have log 8. Okay, let's take this. 2 all over 3. Okay, 2 over 5 log 32. You're being asked to simplify that. So if you have this kind of question, you just come back here. You can see. So you just reverse this. So when you say, okay, you reverse this, that means you bring this one here like this. That is that will be log. Remember I said if you don't have anything here, it simply means log 10. So that means log 10 32 raised to power 2 all over 5. You remember this very law from indices. Like I told you, it's just the mirror of one another. If you have a raised to power x all over y, a raised to power x all over y is the same thing as the white root of a x. So what do you do here? And what we applied here is just the third law here, which says that when you have log base x m of n is the same thing as a log x m. So what you do is just simple, just say, okay, this is the same thing as log 10. You bring this one, the fifth root of 32, as the fifth root of 32 raised to power 2. That's simple and straight. So this is the same thing as the fifth root of 32 is 2 raised to power 2. So you have log 10. So fifth root of 32, or simply you can just, okay, you can still say this if you don't want to put this. Just, okay, this is log 10 2 raised to power 5 multiplied by 2 all over 5. You can see it's still the same thing as this, because 2 here is the same thing as raised to power 5. So you have the fifth root of this is just 2 raised to power 2. So this is log 10 4. So it's as simple as this. Or peradventure, if you don't want to put it that way, just, okay, fine, let's leave it as this. It's okay, this is 2 raised to power 2. Applying, going back to this law. So you just, okay, this is 2, this is equals to 2 log 2 base 10. It's as simple as that. So let's look into another one. Let's look into another one. Let's look into another question. Let's go into a more complex question. Okay, this is fine. You have this is a YX question. This is a YX question. Evaluate without using table, without any tables, you have 3 log 2. Remember I said if you don't have any of the base, it simply means it is base 10 plus log 20 minus log 1.6. So this is a WAEC question. The year is not there, but it's a WAEC question. WAEC question. So all you do, apply all the laws, bring them together. So looking at this, so how many laws is being combined there? You have the 3 laws being combined here. The law 1, you can see 3 log 2. So that means here we have when you have log x m into n, this is the same thing as n log x m. Then you have this is addition. That means you have the second law for the 2 here. You remember you have when you have log m n is the same thing as log, remember, x m plus log x n. Also you have negative here. You have negative here, so it's the same thing as log x n divided by n log x m minus log x n. So let's bring everything together here. And knowing this 1.6 is the same thing, to write this equation first. So you have 3 log 2 plus log 20 minus this is the same thing as log 1/6 divided by 10. So that depends. This is the same thing as this, log 10. So if it's okay, let's write this. Let's make it more elaborate. You say, okay, this is 3 log 2 plus log 20 minus log 1/6 minus, because this is division, minus log, let's put it there, minus log 10. So that depends. So let's bring everything together now. Let's bring everything together using applying all this law. So when we write this, so you have log 2 raised to power 3 plus log 20 minus let's even still keep this before we make it more elaborated, into log 1/6 minus log 10. So what you do now, bring everything together. So you have this one multiplied by this is multiplication, this is division, that's division. So yes, or let's first keep this before we make it more elaborated. Let's still just keep this as log 1/6 all over 10, log 1/6 all over 10. So therefore, what do you have? You have this one as everything into 2 raised to power 3 multiplied by 20. Remember from here. So divided by 16 all over 10. That's all we have. So let's take this more. Let's take this more. So now, if you remember, if you have x all over y all over k, so is x all over x divided by y all over k, so which is the same thing as x multiplied by k all over y. So if you have this, you have this as log 2 raised to power 3 multiplied by 20, right, multiplied by 10, everything all over 1/6. Everything all over 1/6, because this is the same thing as this divided by this. So if you follow this very route, you see this one will have to come here, then you still have your 16 this way. That's what you have, right? Yes, we're right. So now look at this. I need to confirm. Yes. All right, 16. This is the same thing as 16 all over 10, 2 raised to power 3. This is divided, so this 10. Yes, we are right. So now, what do you have? Can we have 2 here? Yes. If you have 2 here, this is 8. 2 here, that is 10. Now, 2 raised to power 3 is the same thing as this. So this 8 will go, this will cancel this. So you are left with 10 and 10. So this is the same thing as log into 10 multiplied by 10. So this is log 100. But you see, we can't leave this here. We can simplify it more further because we've been asked to evaluate without using table. Now, all you need to do, you say, okay, what you have here is equals to log 10 into 100. So what you do is, okay, this is equals to n. Assign an arbitrary letter to it. So if it is equals to 10, from the law of indices, you have this as 10 raised to power n equals to 100. That's not a magic. That's not a magic because, like I said, logarithm is a mirror of indices. That's simply put, it means that if you have log into base x, y, what does this simply means from here? So if you say this is equals to k, you say this is equals to k because you actually want to get this. So it simply means that the k that you have here, so you take this k, which is the same thing as this n, you take this k, now put it all over as a power. So it simply means that, so you have your x raised to power k equals to y. Simple and straight. Simple and straight. So if you have something like this, this is equals to this is 10 raised to power n equals to, because you actually want to keep it in the same base. You want to keep it in the same base. So 100 is the same thing as 10 raised to power 2. 10 raised to power 2. Because 10 raised to power 2 means 10 multiplied by 10. That is 100, because you want to keep it at the same base with this. Remember, like I told you, what if you have expression like this without the log being given a base? It simply means base 10. So this base can cancel this base here. That means your n here is 2. So simply put, that means the question that we're being given, here, the solution to it without using table is equals to 2. That means 3 log base 10 2 plus log 20 minus log 1.6 without using table is equals to 2. All right, please, if you have any comments, just put it at the comment box below. So let's consider another question. Let's consider another question. Okay. Yes, we have another question. Log 8. This is coming from 2008 WAEC mathematics objective question. WAEC mathematics objective question. We have simplify log square root of it all over log 4 minus log 2. Now look at this. Just 2 laws here. The first law, if you have log to base x of n minus log to base x of n is the same thing as log to base x of n divided by n. Simple and straight. Then if for this very other one here, I'm talking about the numerator because you have three equations now. You have a fraction. This is numerator, and you have the denominator. So for the numerator, you apply this law. Then for the denominator, yes. Now for the numerator, remember you have this. So this is the same thing as log x, when you have p n of m. This is the same thing as log x m raised to power n. So let's treat them individually. So now you have log square root of 8 all over log 4 minus log 2. So this is the same thing as log square root of 8 all over log 4 divided by 2 from here, from this very law. So now you have your log 8 square root of 8 log 2. Did you see that? 4 divided by 2, that's 2. So now if you take this one out now, so this is log 8 raised to power 1 all over 2, because this square root means, remember from the law of indices that says that if you have a raised to power x all over y, so this is the same thing as white root of a raised to power x. So all over log 2. Simply put, you can bring this one outside here. So therefore you have 1 all over 2 log 8. This law from here divided by log 2 divided by log 2. So now going back to this very law, that means if you have something like this, you have 1 all over 2 log 8. So we have 1 all over 2 log 8 all over log 2. Now simply means, so if we bring this one here, still we can simply just say, okay, we want to re-express this. This is the same thing as 1 all over 2 log. To put this one into the same log with this, to put it in log 2. So you just say, okay, this is the same thing as 2 raised to power 3. 2 raised to power 3 all over log 2. So now, what we do, bring this 3 here, applying this very law. Yes, this very law here. So you just, okay, this is log 2 all over log 2. So this simply can cancel this one out. So you have your answer as 3 all over 2. So if you have any comments, all you need to do, just put it in the comment box, then we'll get back to you. All right, thank you very much. We've come to the end of an introduction into logarithm. So please try your hands on all these questions from question 1 to 5. Please try your hands on them. They are very simple and straightforward. Log 8 minus log 4 divided by log 4 minus log 2. You remember, just apply all these laws that we've tried to introduce us to. So just try it. Then number 2, log 2 minus log 2 into 2x minus 1 blah 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 equals to 1. So just try it, find x. This is also a YX question, and also try this. This is also a YX question. Then I will want you to try your hands on this. Just do. This is the combination of indices. You know, like I said, one is the mirror of another. Logarithm is the mirror of indices. So you have 2 raised to power 2x minus 10 multiplied by 2x plus 16 equals to 0. I said, okay, I give you an hint. Let y equals to 2x. This will definitely lead you into a quadratic equation. But just try your hands on it. Then endeavor to submit this assignment to the email address that will be given in the description box below. Thank you very much. and have a wonderful time.